Maybe not quite the full solution, because obviously you've not been training for it, and you've not solved 10 questions like this in preparation, so maybe you don't have the whole thing. However, let's go through the solution. And I think there are these points 1, 2, 3, which kind of give you a guidance of how to do the formulation, which is part A. And part B is using the simplex method, and that's what we've been practicing for some time now. And then the interpretation, probably very few people have got that far, but we'll see. We should be able to get it done, because I won't be doing all the pivoting and all that. However, the formulation is quite an important part of it. So part A, formulation. And it starts with picking the decision variables. So typically, some people pick the wrong decision variables and go with the machines. But in these cases, in examples like this, of this type, where the question is how much of this and that to produce, and then there are some limited resources, in those situations, the best model, and quite often the only one that leads to the solution, is the one where you use decision variables for the things that you're producing. However, you have to be careful. So often, and I've seen a couple of examples like this here, you don't want to write x1 is leopard xj, because a leopard xj is a car or a toy, and x1 stands for a number. So you should say what quantity x1 represents. If you just write leopard xj, you don't know what it is. Is it the price of it? Is it how much it costs to make it, or something like that? It has to be a number. So you have to be very precise about that. And when you're precise about what these decision variables mean, then you're less likely to make constraints that don't mean anything. So x1 in this case, or you can call it anything else. You can use L, B, and M if you prefer. I'm using x1 for the number of leopard xj produced. I think it says in a month. Okay, and then you'll have x2 and x3 will be the decision variables for the number of the other models. So Bland, Over, and Moose 99, again produced a month. And these are all the decision variables that you need for this problem. Just the number of things produced. Okay. Then the second question asks you to give the objective. So the objective of a linear programming problem consists of the word maximize or minimize, and then a linear expression in terms of the decision variables. So in this case, the text tells you that the objective will be to maximize the profit. So you can write maximize, you can call it Z or P or whatever. And the profit is given by the profit of the individual models. And if you're making x1 of the leopards, then the profit of the leopard in total is going to be 20x1, and the second one 23x2, and then 27x3. And then we have the constraint. So the constraints come from the limited resources, and in this case, there are two resources that give you constraints, which are the two machines. But then there's also, now you're probably still solving at the back, but can we have a bit more concentration? So the two machines, oh, right, so, sorry. Give back, it says including unit. So if it says including unit, then this is going to be in pounds per month. Okay, and then where we have the constraints, the first one says that if we're using the first machine, uses 2 hours every time we produce a Leopard, 3 hours every time we produce a Blandover, and 6 hours for the last car. So the total number of hours that we use is 2x1 plus 3x2 plus 6x3. 3 shouldn't be more than 200. And for the second machine, we get this. And then it also says that the total number of cars made shouldn't be more than 60 every month. Okay. And an important constraint that many people tend to forget is that, in this case at least, all the decision variables have to be non-negative. Okay, don't forget that one. So that's the formulation bit. That's the first. That's the first 7 out of 20 marks. It's already good enough. Okay, any questions about this? Anybody got anything else? Doesn't matter what letters you use for the decision variables, x1, x2, x3, or xl, xb, xm, or obm, they're all good. No questions? So for the pivoting, I will only show you the tables like this because I don't want to spend too much time on it. Which shows that I'm doing it the wrong way, because here I've put the constraint with the 60 as the first constraint, and then there are 2 constraints with 200 hours. And this is what the first tableau is going to look like based on your system of inequalities. If you want to write them as equations with slack variables, that's fine, but you should get this same tableau, maybe with the rows permuted, because you can write the constraints in any order you want. Okay. I think most people got at least this far. Is that right? Yeah? Now, what do you do for pivoting is, and we've been doing this for quite some time, so there shouldn't be any problems. You look for a negative value in the Z row. By Danzig's rule, you pick the most negative one. If you pick a different negative one, that's fine. It might just take longer or not, depends. So the rule tells us to pick 27. Now, what we want to do is the ratio test. So in this case, 60 divided by 1 is 60. 200 divided by 6 is 100 thirds. And 200 divided by 4 is 5. 50. So the least one is this, because it's about 33. So 6 is going to be the pivot element in this case. And that means that the next tableau should look like this. It's probably too small. And now I'm sure some people did get this far, because when you take it minus 11, which should indicate x1 to enter the basis, now you do your ratios, and you get ratios 40 and 100 and 40. And some people ask, what do you do when the ratios are the same? What do you do? You can choose any of them with the same ratio. What you should expect is that one of the entries in the val is going to be 0 in that case. Because, as we talked about it, the ratio test makes sure that you don't get anything negative in the values of the variables. So if you have 2 of the same ratio tests, then you're expecting in the next tableau to be a 0 there. So if you do S3, you get this tableau. There's not much point going through all the entries, of course. And this tableau is now optimal. Why is it optimal?
No negatives in the
Quite right. So you stop pivoting when there are no more negative entries in the objective row. It's good to know. Some people don't stop pivoting until they've put all the x's into the basis, and that's wrong. So the right thing is to look at whether there's any negative entries in the Z row. If you decided to do the pivot in the first row, so S1 leaves the basis, and you get this tableau, and this one's not optimal. And here you have to do another pivot, which gives you this solution. Okay, but when you compare, I'll make it. So this is something maybe a little bit ahead of what we were doing in the lectures, because you have two different tableaus, the top one and the bottom one, and they both appear to be optimal, and that can happen. So there are, but as you can see, they actually both correspond to the same optimal solution, where x1 is 40, x3 is 20, and everything else is 0. So then that's the answer. And the last bit that remains is the interpretation. So you go back to what x1, x2, and x3 meant, and you say what it means for the production policy of the company. And in this case, because x1 is 40, you're supposed to produce 40 Leopard XJs, 20 Moose 99s. The slack variables being all 0 means that all constraints are satisfied with equality, and the monthly profit is 1,340. Any questions? Well, if I don't see you in the lab this week, then have a good Christmas and see you in January. But I hope to see as many of you still in the lab lessons. Goodbye.